we have the section regarding the columns in the superstructure. This is cross section over here, and we have different details over here. It is very important first to understand the drawing, as I said earlier. And now as I have mentioned already, in the column next we have 4 bars over here, so same goes up till the top as well. And we have rings over here. Cross section is 225 by 225. It is mentioned that we are using 6 mm 150 center near junction, thus rings, and at mid we are using 225 center to center. Let's look about what are these, the junction and the mid. And cover is 25 mm. Now let me simply go here. We will start right from this position. We have find out up to this position, but again we will give the lap to it and start right from this position. So here in the superstructure column, first of all, it is very important to check what is the height from the grade slab up till bottom of our slab. So it is total of 3000 mm. Right from this position up till here, it is total of 3000 mm. Now next to it, it is mentioned here that rings that we are using right from this position up till here on h by 6, it is 150 centimeter. So what is h? H is basically the total height right from the grade slab up till bottom of our slab. So it is h. So what was that? 3000 mm divided by 6 will give us the value of h by 6. So 3000 divided by 6 and 3000 divided by 6. So it is total of 500. Mean h by 6 is 500, and it is clearly mentioned over here. On h by 6 we are using rings as 150 center to center, and h by 6 is at the bottom and h by 6 is also on the top. And at mid and remaining portion, definitely we have 2000. So what will be the mid value? 500 we need to deduct from the bottom, 500 from the top, and remaining value is 2000. So at 2000 span we are using 6 mm 225 center to center. So this is the ring detail, and this is how we can find out. Now in order to find out longitudinal bars, first of all we need to find out this height right from this position up till this position, top of our slab. Then we need to deduct a concrete cover over here from the slab. It will give us a total longitudinal, and then we need to find out this development length over here. So let's go into the Excel and start finding right from the longitudinal bars or the dowel bars. So here we have Excel, serial number S1, and this is C1. In our plan we have only C1. If in your case you have C1, C2, C3, you can do the barbaric schedule same as I am doing here for the individual C1. Same goes for C2, C3 as well. The size could be different, bars could be different, but the process is same. 225 by 225. And next, what about the height? Height is 3000 mm. Remember this one, but we need to include the slab as well. 3000 is basically right from top of our grade slab to bottom of our slab, and we need to add the thickness of our slab as well, that is 150 mm. So it is total of 3150 mm. Next to it, a particular placing of bars. So this is a dowel bars. Spacing, there is no need to add the spacing over here because these are 4 bars, the longitudinal bars. Next to it, what we need to do is we need to create a shape. So I'll click on this drop down, draw border option, and I'll simply create a shape over here like this. So this is the shape. On the top we have bend and development length. Next, what about the bend or the directions? Bend directions, so we have only 190 degree bend, so equal to 2 into dia bar. It is okay. Next to it, what we need to do is we need to add here the bend or development length. And development length, remember, if it is 90 degree, we will add here 16 into dia bar. Now next to it, if we have any kind of overlap, so there is no any overlap. We have already find out the overlap value. Now we'll find out the straight value and then this development length. Next to it, we have dia bar, and dia that we are using here is 12 mm, and based on this you can see the values over here. Concrete cover in the column is 25 mm. But remember one thing, while finding the length of this bar, we will deduct the concrete cover from the slab from the top. This is very important to understand. Let me show you. This bar is going right up to this position, and this is a slab. We need to deduct the concrete cover from the slab. So concrete cover in the slab, it is not mentioned over here, but it is mentioned over here. It is a total of 15 mm slab and RC wall. 15 mm. remember this one. So I'll put here 15 mm because we need this concrete cover. Next to it, what we need to do is we need to find out number of bars. We have 4s over here, and number of members. We have 13C1 over here, like 13F1 over here, 13 column next, 13C1, and then total numbers will be equal to number of bars multiplied by number of members. Hit enter. Now next to it, we need to find out the total length, and in order to find out total length, first of all we need to find out the cut length. First of all we need to find out the total height. Now from the total height up till slab level is 3150. We need to deduct only concrete cover from the top. Important. So minus concrete cover from the top is this one. Hit enter, and this is the value we need, 3125. Sorry, 3135 I think it is. Yes. And next to it we need to find out this one as well. It is equal to this one. And now it is time to find out the total length, and total length will be equal to cut length, this one plus this one, and then minus we need to do the bend deduction, this one, and multiply it with total numbers. Divide it on 1000 in order to convert it into meter. Hit enter. So this is basically the total length for these longitudinal bars here in the column in the superstructure, and this is how we can find out this one. Hope you understand. Number 2, we are going to find out the rings as well. We have different spacing for the rings. We have rings on h/6, we have rings on the mid, so both of these we will find out separately. Up till this position it is okay for us, and now we know what is the h/6 value. The total mid value, the h value is 3000 divided by 6 will give us a value of as 500, and we have h/6 at the bottom and we have h/6 on the top, so it will give the value as total 1000, where we need to place these rings with a spacing of 150 cm I think. And bar detail, so these are rings, and next to it spacing of the bars. So spacing of the bar on 150 center to center, it is 150, on h/6 it is 150 center. So I'll put it as 150. Next to it we need to create a shape for the ring. So go here in draw border option, do the same thing as we did in the column next. And next, as I said earlier, we have 390-degree bends and two 135 degrees. So it is equal to 3 into 2 into diaph bar. It is okay. And for 135 it is equal to, we have 2 into 3 into diaph bar. If you have not attended the basic training, then it is difficult to understand you here. Next to it, we have bend or the revolvement length or the hook length. So we are taking here 2 hooks into 14 into diaph bar for the rings. Remember this one. Now no overlap over here. What is the diaph bar? 6 mm we are using here for the rings. Concrete cover here in the columns is 25 mm, and number of bars, so it will be equal to, span is 1000, top and the bottom I am talking about, 500 at the bottom, 500 at the top, span divided by spacing is over here plus 1. So it is total of 7.66, mean you can round up this one in order to convert it into 8 bar. Round up, start the bracket, comma, close the bracket, hit enter. Next to it, multiply by number of members. How many members we have? Total of 13 found. C1 we have over here, and then total numbers will be equal to number of bars multiplied by number of members. Hit enter. So these are the rings here in all of these columns, 104 on h/6. And in order to find out the total length, first of all we need to find out the cut length. So it is equal to 225 minus concrete cover from both ends. And next to it, this is equal to this one, and this is equal to breadth minus concrete cover from both ends, and simply this is equal to this one. Now let's find out it over here. Now for the total length, it is equal to this one plus this one plus this one plus this one. Next to it, what we need to do is we need to do the bend deductions over here. Before that we need to add the hook length as well. This one, we have 2 hooks over here in the stirrups, minus we need to do the bend deduction 90 degree and 135 degree, and then multiply it with total numbers divide it on 1000 in order to convert it into meter. Hit enter. So this is basically the total cut length, our total length for these stirrups on h by 6. Now we will find out for the mid as well, number 3, and this is same up to this position. And now it is time to find out the mid value. Remember, h by 6 is 500. At the bottom we have 500, at the top we have 500, and now at the mid what will be the value? Total is 3000 minus 1000 will give us a value as 2000. So this is where we need to put these rings with the different spacing. Again the rings, and what is the spacing on 2000 span? Let me go here. This is 2000 span, and here we have 225 center to center. Remember this one. So I'll put it here as 225 center to center. Now let's create a shape for this one as well. Okay, next to it, what we need to do is, let me create it over here as well. Now next to it, we have same bend deductions over here for these rings. Only thing is we have changed spacing over here, nothing else. Hook length is also same, so paste it over here, no problem. You can see, double click over here, the same formulas are going to paste over here, and no overlap. So put the dia bar, and according to that you can see the values over here. And concrete cover, now for number of bars we will go here is equal to span is over here, and span is where span divided by spacing is over here, spacing plus 1. Hit enter. So we need a total of 9.88 bars over here. Span divided by spacing. Yes, let's round up this one. Round up. Start the bracket, comma, close the bracket. These formulas are very important, dears. And then total numbers multiplied by number of members, we have 13 columns, and then total numbers will be equal to number of bars multiplied by number of members. Hit enter. Now we have find out total numbers over here. It is time to find out the cut length. Now for cut length, first of all, it is equal to length. Everything else is same. Remember this one, because cut length is same, everything is same. Only thing is we have changed spacing over here, minus concrete cover from both ends. And remember, this is equal to this one, and this is equal to this one. Now in order to find out the total length, what we will do, we'll simply copy this formula and paste it over here. Let's check this one. Okay, copy it again, paste it over here, double click over here, and you can see this one plus this one plus this one plus this one plus hook length minus bend deduction multiplied by total numbers and divide it on 1000, and you can see the values over here. So we have find out the bar bending schedule here in the